Do you have an explanation for this, Eva? Why we have to assume the Earth is flat, and then
Yeah, I was working through
mathematically?
that.
Hold on, I'm almost done.
Yeah.
And then mathematically program it into a ball to confuse people into thinking that it is one.
So if the refraction factor is 7 over 6, what is the refraction
Are you
coefficient
not
that goes
answering?
with that?
You're not answering my question. Why do we have to assume that the Earth is flat to do bathymetry? We're talking about sonar.
Because we don't.
I just
So now
showed
my
it. Do you
question.
want me to show it again?
No, I would
Oh,
like an
so
answer to
you're
my
you're gonna come
question.
up here and lie?
Yes.
Oh,
Yes, sir.
Have you recorded, you idiot? Oh my god.
So if the
No,
refraction
I'm actually
factor
no. I'll take the
is
W. I'll
7
take the
over
W.
6,
You guys have a good day. You just lied to like 50 people
run
and whoever sees
slowly,
this when I post it.
run
Have a good day, bro.
slowly.
The
look.
efficacy of how we build infrastructure is contingent upon planar geometry. So the Earth cannot be a sphere. Aviation makes no physical corrections for Earth curve. Microwaves travel line of sight. Water always finds its level. Seems like the only way we can do anything, technologically speaking, is if we assume that the Earth is a sphere or is flat, right? Unless you have evidence that it's a sphere.
And you went into that argument still last time, and you still did not substantiate the fact that distance. Well, you were talking about the building in 500-foot increments where there's a negligible amount of curve. And then what you were talking
No, that's
about was
not what I said, actually. I said we measure in 500 increments, but then we compile that data together and use it to build infrastructure. We measure in 500-foot increments and then we compile it together, so it becomes more than 500 eventually. It becomes very long distance eventually. And where there's no measurements for Earth curve formulated into it.
Let's see here. I just got a text. Sorry. And okay. So
Who did you share it to?
share to a couple friends.
Yeah, I bet you did. All the anti-flat earthers you can name. That's cute. That's adorable, though. Nobody can really save you from me. I mean, unless you believe in like Jesus coming back and saving you, that's fine.
What's wrong with them sharing the live to mutuals to support each other or just hang out while talking about the topic?
Oh, it's more or less he's gonna share it to people that are gonna potentially try to save him. But I'm just calling it what it is. You can believe that if you want.
No, you're going to
No, you're forgetting people that go on
I
live
didn't-
can literally just have people to have side conversations while also just waiting for more people to talk about
Well,
the
I never
problem.
got a
I
response
don't know
to
why we
my.
always have to have this like condescending tone of the superiority complex.
Okay, that must be what it is. I never got a response to my position that you misrepresented, which is that we have to assume the Earth is flat relative to our local position within 500 feet. Then we compile that data and we build infrastructure based off of it, based off of increments of 500 to 1,000-foot measurements. We never compensate or incorporate curvature of Earth unless we do geodetic, which then we use a coefficient of 7 over 6r, which fluctuates the radius value, which is obviously the object in question. It turns it from a standard radius value to a radius value of 1.66. Is that 1.66? I believe so. Could be wrong on that. Or maybe 1.23. I don't remember. But it's not the radius value as it currently stands. So you literally have to make the radius bigger, flatten the Earth to make measurements work. So why would we have to do that?
Okay, so give me the source for that.
Geodetic surveying. It incorporates 7 over 6r. This is like any plane surveying. Well, not plane surveying, but if you look into like WGS 84, they would use it. It's the coefficient of K.
Let's see here.
Oh, it's to account for refraction, but it changes the radius value of the Earth, Various says. That makes sense. Wouldn't the radius value of your Earth be your constant? Does the radius value change?
Required for large-scale project covering areas greater than 250 kilometers squared, such as national borders, intercontinental railways, and mapping.
I love how his response to me asking him if his radius value changes, he says what? Yeah, the radius is the object in question that should remain constant. We should not use a formula
I
like
am
7.
reading something.
Okay.
I am reading something.
I'm responding to the people that you invited to attack me.
I invited some mods that are not even here.
Good.
Yeah, these people's already been here.
No, the
Guys, I know
viewership
y'all
went
shared
up
the live.
significantly. The viewership tripled since I got here, but who's counting?
Yeah, because you shared the live probably to a group.
No, I
And
shared it
also
to
we're
one
on a
person who
public-
specifically
and
asked
also we're in
me
a
to.
public live where anyone can just scroll by and just choose to either stay and engage.
What about
or
you,
just
big
scroll
fella?
on.
Why do you think we have to change the radius value of the Earth when we do geodesic surveying?
I'm not gonna lie. A question I'm more curious about is when it comes to flat earthers.
So do you
how
don't-
deep do they
you don't
think the
know?
planet can get?
You don't know? Do you know what happens if you make the radius of a sphere bigger?
What?
The ball gets bigger, and the surface gets flatter. In microwaves, they use a coefficient of k equals infinity. They assume the radius of the Earth to effectively be infinite in some scenarios. Because that's the only way to make it work in link, planar, and path loss. Mathematically.
Which source specifically are you talking about for geodesy?
If you look up geodesic surveying 7/6R coefficient of k, you should probably find some sources on that. Stuff that I already said.
Okay, because there's actually something published from 2020 here.
Okay.
That is, let's see here. With numerous facts, research, and evidence, the Earth is well known and established to generally be sphere shaped. Oh yeah, there's an entire paper here talking from, let's see here, ResearchGate, talking from yeah, they actually address your exact point here.
What do they say?
It's a little bit of a read here. I'll show you. Camera.
You gotta move your
So there's,
your prompt potentially. There you go.
yep. So there's this. This is
Latitude and
from
longitude. Oh, okay. Well, where does
ResearchGate.
it talk about? What did you want to show me?
This was from. Okay, so
I don't care where it's from. Just what did you want to show me? If it's from ResearchGate, then it's whatever.
well, yeah, but I'm giving you the source to actually look it up and then read it over yourself.
You're
'Cause
you're bringing this up to
you and
show
I
me
can-
something. So show me.
I'm just saying that there is a paper that addresses your thing. That's what I'm saying.
Okay.
I
Where
haven't
does
read it yet.
where does it compensate for curvature of Earth, and how does it do that?
I just read this paper.
You did not just read all that paper.
Okay, hold on. I said so yes, I did just say that, but at the same time, I'm saying I will read the paper, but yeah.
Oh. So you haven't read it, and you don't feel like reading it in front of an audience of 30 people? Where does it
I
say
have
that they
hyperdyslexia.
Where does it say that they changed the radius value of the Earth? You said it addressed that. Why would they do that? Does it explain why?
It deliberately, as soon as I looked it up, that was the first thing that popped up when I looked that up.
Okay. And you did not cite it. You didn't cite it. Do you know what a citation is?
Okay. Yeah, it says debunking flat Earth from geomatics perspective.
Okay. How does it debunk?
I looked up the thing, and the first thing that popped up was that exact paper because
Okay.
I looked up I looked
How
up the
does it
geodetic survey.
debunk it though?
Okay, so I'm going to say right now, I do not know enough about geodetic surveying. So if you're talking about that, I do not know how to actually address that. The thing is that there is still observable stuff of like, okay, like you can fly in a plane and you can go into sunset and you will see the shadow of Earth's curvature in the plane from the window.
You do what?
So if you fly into, so if you're in a plane, if you're flying on the window that's facing the east and you're flying into sunset, you will see the shadow of Earth's curvature. I have a picture of it.
Show me.
Yep. I took the picture myself from the window.
I don't fully. I guess you're saying like you see shade, like, and you're just like that means the Earth's the ball. Like I don't understand.
Okay. Send the bus. Here, can I share it with you?
I'd prefer to just like look at it here. If you share it to me, I'm not going to be able to open it while I'm here. I can't address it with you.
I have a photo. Man, I have a ton of photos. I need to delete some of these.
Relatable.
Okay.
Yo, I have to mute myself to fucking laugh at these dude.
My internet just crapped on this.
I'm sorry?
My internet just crapped out on my iPhone. I
Your
gotta
eye?
wait for it.
Oh, that's unfortunate. How does this?
Okay. What?
How does this prove that the Earth is curving? What is
Because
the
if
argument?
the sun has to go, or so actually, wait. Let me ask you this. So
What?
if the
Answer my question with a question. Come on, man.
No, I'm trying to figure out. I'm trying to figure out a baseline to go off of.
Oh, you don't
You're
have
going
one?
to continually laugh at that.
I laugh when
that-
people use sophistry. Yeah, it's kind of funny.
Okay. The thing is that I'm trying to figure out the baseline for how you think the Earth is actually looking from the standpoint of where the sun is at, where the moon is at, like what the map of the Earth looks like. What is the like where's your actual evidence for, or what models do you use?
Okay, well, first and foremost, falsification is independent of replacement. We can falsify the globe model without needing a replacement in our back pocket. That's never been a requirement. You were given specific metrics of the Earth. It's supposed to curve at a rate of 8 inches per mile squared. That has definitively been debunked for probably going on like 2 decades, if not longer. If you go all the way back to the 1800s with Samuel Rowbotham, you can just read his books on it as well. But the sun and the moon move over the Earth, bro. And it's just a kinematic equivalence from that point, right? Light attenuates, the whole Earth's not illuminated. How does this prove that the Earth is a sphere? Me explaining how things don't work on a sphere proves that it's a sphere? How does that work? Yeah.
So you're talking about kinematic influence.
No, kinematic equivalence. Kinematic equivalence.
Kinematic equivalence. Okay.
Mm-hmm.
In what? So physics, the equivalence principle. I don't see how that actually substantiates the like. Where?
Well,
where is
kinematics?
what does the sun look like? Kinematics is just like it's kinesis and it's motion.
It's motion relative to another object. Yeah.
Yes. Okay.
Okay.
Here's
So when we watch the sky move, right?
what does the map look like for flat Earth?
Okay, you're not understanding. when you watch the sky move, right? Relativity even says, this is why Einstein had to correct himself from general relativity to special, because he had to admit that there's no definitive way to prove that the Earth orbits the sun, or vice versa. He said that either coordinate system could be utilized, right? There are direct quotes from him saying that in the special and general relativity.
So I still need, like, that's not necessarily answering the question. What does the map look like?
There. Okay.
for the Earth?
Let's go down this path. Let's do this then. There is no map of the Earth. Period. Right? You don't have one. Do you have one? Which map or model do you use? I don't use one. I'll admit I don't use one. I answered your question.
Roadmap.
Really? How many times do you use a globe to navigate with XY coordinates?
I don't have to.
Oh, you don't use a globe to navigate, even though you just said you did.
No, I didn't. Well,
Yeah,
okay,
yeah,
yeah. I
you
used
did,
the globe
actually.
map. I
Yeah.
used the globe map.
Which one? These things have names. Which one?
Like Google Earth.
Which
Google
uses
Maps.
which uses XY coordinates that derived to a latitude and longitude system, which is in correlation with the sky. We got latitude and longitude from the sky, assuming the Earth is flat, to take angular measurements of lights in the sky, bro. That's literally where latitude and longitude comes from. Longitude comes from our measurement of the sun, right? The sun appears to move 1 degree, or 15 degrees per hour. Every 1 degree would be a line of longitude, okay? But it could just be the sun moving. The Earth could be stationary. This is kinematically equivalent.
Okay. But where? Okay, so then where is the sun?
Where is the sun? It's above you.
Okay.
Do you
Let
not
me rephrase
understand?
the
Do you not understand that, like,
Let
the
me
globe?
rephrase the question. How high above the Earth is the sun?
Who cares? If you're asking non
It's
sequiturs,
a very
does
important question.
really? How does
it's
it
a
prove
very
that the Earth is
important
curving or orbiting it?
Because if the sun is anywhere near, within, like, if it's in the atmosphere, which a lot of flat earthers do purport that it is, if it is within the atmosphere, the catalytic reaction of the sun.
How do you know what the
hitting
sun's
any
made
gas-
of?
Because we can use any type of,
Like what?
pings of infrared, or
In
not
infrared?
not infrared.
Oh.
I forgot the exact term, but yes, we can tell the matter that's in an object
How?
by using a dish to actually read.
How do you tell that what you're picking up isn't just coming from the cosmic microwave background distribution, radiation distribution all around the Earth that aligns with the sun's ecliptic? How do you know that it's not just that? How do you decipher what's picked up between the
Because
natural
we can
radiation
tell
from, like, the Van
if
Allen
we-
belts and stuff? Like, how do you know that you're not just picking
The
up
Van
that stuff?
Allen belt is radiation. The Van Allen
I
belt is
just
simply
said that.
the-
I just said that, right? I said, how do you
Okay.
know? Listen.
So the radiation doesn't have a tangible mass.
Hear me out, bro. What I'm saying is, right? How do you decipher between the radiation that we get from the sun and the radiation that's already surrounding the Earth? How do you know which is which?
Okay, that's not even the. That wasn't even the premise. That wasn't even the premise.
You said you knew the
I'm not-
molecular makeup of the sun because of radiation distribution, but you'd have to look through a massive amount of radiation distribution to get
I
a
never said
measurement.
that I knew the makeup of the sun through radiation distribution. I never said that.
What did you
I
say?
never. I said that we can tell what the sun is made of through a way of actually, like, we can.
Do you want me to tell you what you guys do? You use spectroscopy.
Okay, spectroscopy. Yes.
Yeah, which is
So
measuring like reds and blues in a prism like lens, right? Which requires electromagnetic radiation. Okay, so I'm just asking, how do you decipher the difference between radiation from the sun and radiation which is already surrounding the entire Earth, even on your model? There's a cosmic microwave background distribution, CMB. Okay, like there's radiation everywhere. So how do you decipher the difference between what's coming from the sun and what isn't?
If you think that I know how to actually decipher that, you are wrong.
Well, then don't
But-
make claims as to the sun's molecular makeup.
I can refer to papers, and I can refer to all of the stuff that
Last
I have been.
time you referred to a paper, you put it away and didn't just you decided not to read it.
Because I don't want to be wasting people's time on having me try to read things.
Yeah,
I am
watching
very
you try to read might take a while. You're right. Maybe we should talk about geometry. You're gonna drop me?
Stop.
Maybe we should talk about geometry.
Stop.
You're gonna drop me?
You gotta learn how to be fucking respectful.
Yeah, I'll apologize to you, bro. It was the last thing that I said was a little unnecessary. However,
I think everything that was done.
I kind of disagree, right? Because you're saying that the sun would destroy our entire atmosphere. On what premise is that built upon?
The immense heat.
The immense heat? Did you know that the sun heats up the earth through convection?
Well, yes, but it's also got 93 million miles of distance in the globe model.
No. In the globe model, right? But it heats up the
Yeah.
earth through convection, which is just excitement of particles, right? So there's more, hear me out though. There's more particles at the surface. We agree on that, right? So there's more particles to excite at the surface. That's why the surface has the highest temperature. And as you go up, temperature decreases. Okay. So outside of that, right? Like, that's why I'm asking you, right? Because you're claiming what the sun's made of. Well, I don't make that claim. So I don't have burden of proof.
Okay.
Does that make sense?
Yes. So let's say this, okay? We'll say that the sun is made out of whatever it is, okay? So it doesn't matter about that. But at the same time, it is exciting particles, and it is a very high temperature because it has to be in order to provide that convection heat.
Well, I wouldn't
There-
even grant you that necessarily, no.
Okay.
I would argue that there's no way to know what the sun's made of, because we tried to figure out what the sun's made of, and you couldn't provide an accurate depiction of what the sun's made of, or establish how you would decipher the difference between the radiation that's already distributed around the earth relative to the radiation that comes from the sun. So
I am curious how you. Well, actually, it'd be switching topics, so I won't
No,
do
go
it.
ahead.
But
Go ahead. I don't
so
care.
the Parker Solar Probe. What are your thoughts on the Parker Solar Probe?
It's made of materials that would melt, but I guess you would claim that it's in such a low pressure system with not enough atoms to carry the heat. But I looked into it. It's made mostly of carbon, which has a melting point of, I believe, like 1800 degrees Celsius. And the corona, which is the uppermost atmosphere of the sun, the area of which it is allegedly supposed to be orbiting, has I think it's like anywhere from like 3.5 to 6.5 billion degrees or million degrees Fahrenheit. So I made a video on that actually when I first started doing TikTok, and it's amazing. I still remember as much as I do because I haven't spoken about it since. But I don't give credence to that. I don't give credence to a vacuum. You'd have to prove that we're adjacent to a vacuum. You made a claim there. It's a begging the question fallacy.
Well, okay. So the thing is that we have the Parker Solar Probe giving us at least some sort of imagery of flying closer and closer to the sun and going through a perihelion orbit around the sun.
That's your claim. You'd have to supply evidence that we could even get it there. Like, do you know anything about orbital mechanics?
That's from the United Launch Alliance's actual website, where I actually,
Okay.
the Parker Solar
So-
Probe is one of the things that I definitely do know.
But that's okay. But you don't, though, because you had to source an authority figure to provide your evidence. So I'm saying, like, you don't actually know. You trust that it's there.
So is the merit based on only stuff that you can quantify?
Quantify means count. So I don't know what that has to do with anything. No, it would.
or substantiate. Like,
I would
if
argue it's not a pure imperialist worldview, but we have to take all things into consideration, right? Like, if your claim is that there is a probe that is in a vacuum, well, then the most logical question that I can ask you is, how do you have a vacuum that's expanding, right? Like, what is causing it to expand, and what is it expanding it into? What is it expanding into? And how is it adjacent to a pressurized system, multiple pressurized systems? If you believe the whole heliocentric model, every alleged planet would have an atmosphere that is adjacent to, in contact with, a vacuum of 10 to the negative 17 torr. Like, this is in direct violation of thermodynamics, and even Stephen Hawking acknowledged that.
Okay, I would love to see the topic of where Stephen Hawking says that
He wrote it in the Book of Time, I think that is what he called it. I'd have to load up my laptop.
if you want to provide sources and do that, I implore it, and I will gladly look into those sources. I do not like.
It's a
Obviously, I
book
don't
that
know.
he wrote.
I know that it's a book that he wrote.
Yeah.
The let's see here. Let me. Okay. The thing is that you can't substantiate it if you don't use gravity as the metric.
Substantiate what?
Substantiate an atmosphere or the ability to have an atmosphere
Yeah,
without gravity.
Of course you can.
Like,
Terrariums have atmospheres.
okay, no, gravity. Like, okay, so
What? That's what?
no, hold on.
Okay.
Let me
Yeah.
Let me explain. So here's the thing. The atmosphere for Earth in a globe model does not have a barrier. It does not
You're
have
right. That's a direct violation of the second law of thermodynamics. Yeah.
Okay. Except for the fact that there is something that would be pulling it down. There would be something that would be
How do we prove that gravity's pulling it down?
because gravity is an attractive force. Gravity is a all-encompassing attractive force.
Einstein supersedes Newton. It's actually a geodesic mathematical path that we classify as space-time, non-Euclidean geometry. It's not a force. Newton's was outdated. It required an ether. It didn't have a time variable, so you can't really use like the mass attracting mass thing anymore. We don't teach that in like the highest levels of academia, and quite frankly we shouldn't really teach it to children. But it's simpler to understand. Oh, I found it. I found the quote. If you want me to read it.
Yeah, go ahead.
Okay, this argument about whether this is not in relation to like this is in relation to the expansion of the universe or the entropy of the universe, like where the matter came from, because it's more of like an atheist talking point, because they'll claim that like matter just exists and just came from nowhere. But whatever. This argument about whether the universe had a beginning persisted into the 19th and 20th centuries. It was conducted mainly on the basis of theology and philosophy, with little consideration of observational evidence. This may have been reasonable, given the notoriously unreliable character of cosmological observations, until fairly recently. And then he quotes the cosmologist Sir Arthur Eddington once said, quote, "Don't worry if your theory doesn't agree with observations, because it is probably wrong." And then that's where the quote ends. But then Stephen Hawking says, "But if your theory disagrees with the second law of thermodynamics, it is in bad trouble. In fact, the theory that the universe has existed forever is in serious difficulty with the second law of thermodynamics. The second law states that disorder always increases over time. Like the argument about human progress, it indicates that there must have been a beginning." End quote.
Okay.
And that is from The Beginning of Time. That's the title of the book.
Beginning of time. So I'll read that just so that I can get the because that was a lot of words and I don't remember all of it.
Do you know what the second law of thermodynamics is?
The second law of thermodynamics. Okay, wait. First law. Let me refresh my memory.
I can just tell you, but if you want to Google it, that's also fine.
Yeah, I will gladly admit when I don't know something off the top of my head.
Yeah, not a lot of people do.
Second law of total entropy, because entropy, natural state of any spontaneous process, either increases or remains constant. Okay.
No. Entropy, no. Second law of thermodynamics. Hold on. I'll do it so we can like compare.
Right here
we'll compare notes. We'll compare notes. I'll do it as well. We'll compare notes because I can define it a lot better than that.
Give me a second, Linda.
Oh my.
Yes, I am.
Hold on. So, first and foremost, do we know what entropy is?
Entropy is the end of things.
No, it is. It's disorder. It's disorder. That's what.
Lack of order, gradual decline. I was thinking about the gradual decline.
Yeah, the total entropy or disorder, right, of an isolated system will always increase over time. So the best way to explain this is like a flower grows from a seed to a stem to a root, whatever, and then it decreases, it withers over time. Human beings do the same thing. We start off strong and healthy, we wither over time. The universe, because of this, everything would have to follow this same principle. Everything demands a beginning, which also ties into the first law, which is that energy cannot be created or destroyed. So then the proverbial question then becomes like, where did the energy and the mass of the universe come from? And I don't take you for an atheist. It says on your screen that you're not, so I don't want to take it there. But atheists will often say that the mass and the energy has always just been there forever, and it's like that can't work though. There has to have been a beginning. Entropy demands a beginning. So, but anyway, not entirely sure how we got stuck on that. Yeah. Yeah, I read that. I even referenced that when I was saying it. When I was speaking, I referenced that your prompt says you're a Christian. Although you don't seem to align with the cosmological depiction that is in the book of the Bible. To attack Drills in the comments, if infinite regression is of course illogical because infinite does not exist. Give me an example of something that is infinite without begging the question and assuming energy or the universe. Infinity itself is an illogical and irrational concept. It's even an irrational number in mathematics. It doesn't have a finite level of integers. It's not something that you can fathom. It is by definition illogical. It's strange that people want to die on that hill. Anything but admitting that our ideas of space might not be real, I guess. I was referencing someone in the comments, not you, buddy. Not you. If you want to get back on the topic, though, you can ask me another question if you want.
I'm just trying to... Sorry, I just got... Okay. Because we were talking about entropy and then the disorder of things, and then the... I just need a refresher on what we were talking about, because... you said that it violates the laws of, or the second law, if we have an atmosphere enclosed around a ball.
Yeah.
Correct?
Yeah, if you have no. If you have an atmosphere of high pressure adjacent to a vacuum, high pressure always seeks low pressure. That would be caused by disorder. That would be caused by entropy. Things try to mediate, so we have pressure mediation, similar to how you crack open a soda can and it goes psh, because the carbon dioxide, which is higher concentration than the atmosphere out here, is going to seek equilibrium with the lower atmosphere out here. So if we have a high pressure system on Earth and a low pressure system like a vacuum, just 70 miles up or whatever they claim, then high pressure would seek low pressure. And the antithesis for this is always some magical word called gravity, but I never get like a definitive explanation on, or a practical explanation on how that works. Because PSI is measured per square inch, right? So if we measure 14.7 PSI, that means it has to be pressing off of something,
Well, so, okay. Pressing off of something, technically, yeah, I get it. The thing is that, so wait, go back to the sentence where you were talking about gravity and, like you said, this magical thing called gravity.
Yeah, it just serves as the band-aid for the globe depiction, right? Like, why does water always seek its level, but it sticks to a ball? Well, that's gravity. Why do people stand upside down? Well, that's gravity too. Why does the atmosphere get to defy natural law? Well, that's gravity as well. And gravity is entirely theoretical, so I don't know why we let theories debunk natural proven laws, but that's not my position that I take, so I need like a practical explanation.
So my rebuttal to that is the fact that through each level of the atmosphere, because the atmosphere is actually a lot higher than 70 miles as far as I'm aware. Let me fact check myself on that.
The Kármán line is about 70 miles up.
Okay.
If I remember correctly. Yeah, you could be right. I don't know.
Okay, so atmosphere thickness is its thickness ranges from
62 miles. Kármán line, which is where space allegedly begins.
Yeah, well, space is technically because it's so okay. I won't use AI overview for this one. I will actually look at okay.
If you go to the bottom of the AI overview, it has the sources that it's using to give you those numbers.
Oh yeah. But it says so I know that you're not going to trust NASA, so I'll find a
No, go
different
for
source.
it. I would, for something like this,
Okay.
that's their claim. Of course, I would trust them to be accurate in their own claim.
6,200 miles is what they say. So
I'm sorry? 60 to 100.
60
Well,
yeah,
okay.
60.
62 miles is where the Kármán line is, though. So that's when space
Yes.
begins. That's what I mean. That's what I said.
Yes.
Yeah.
Yes, that is what you said.
Yeah.
The thing is that as you approach higher and higher up areas, you get less density. So therefore, if you have you have 99% of the atmosphere. I'm speaking in vagaries here. So 99% of the gas that is in the atmosphere is actually very low to the earth, and then as you get higher and higher up, you're just dealing with less and less density. The more heat hits something, the more space it causes between it. So like gas is obviously hotter than the liquid generally, and it will actually be the expansive part of it. So gas is always more spacious between its particles than liquid or solid.
Okay. But there's an inverse square law proportional to what you claim to be gravity. So it would get weaker as you move away from Earth. So I'm supposed to believe when gravity is weaker, it's able to contain the Earth's atmosphere?
Well, at least in small parts, because like realistically, our
This would be the
planet gets
whole. This would be the 100th percentile.
Okay, yes. So realistically, there's solar wind that hits us from like whatever the like solar prominence. There's like those big flares. I forgot the name of them off the top of my head, but there's those solar flares. They actually knock a little bit of particulates off of the top of the atmosphere every single time they happen. There's solar winds, and then you have like every time you.
But you're not attacking the argument though. You're that's a non sequitur.
Well, I was addressing what you were saying though, because like there is a very thin layer of gas at the top of the atmosphere that is basically negligible compared to the overall proportions of the atmosphere itself. So like you have 99% of the atmosphere down here, and then that remaining 1% is all the way up here. So
let's break this down into simplicity, right? Like, can we demonstrate gas pressure without a container?
On Earth, no.
Okay. Can we demonstrate a vacuum without a container?
On Earth, no.
Okay. Can we put gas pressure inside of a vacuum without it mediating?
No, that would be no.
Okay. So do you see why this goes against every known gas law?
I see what you're saying.
Yeah,
I see what you're saying. Yeah. I am trying to figure out how to address it in my words because, like, I understand where you're coming from. I understand the point that you were trying to make.
What if the Earth's just not a ball and it's in a contained system? This really solves this vacuum catastrophe that we find ourselves in.
Except there is evidence for all the stuff that, like, there's evidence for curvature. There's evidence for the fact that in the southern hemisphere, the stars turn counter to the northern hemisphere.
Let's attack this for one at a time. So what's the evidence for curvature? What is it?
Well, so the evidence for curvature is the fact that when you are looking at, when you are higher up, you actually, so let me put it this way. Higher vantage points mean that you see the sun for longer. If I'm on top of, like, I got Mount St. Helens in my, right outside my window right here. If I stand at the top of Mount St. Helens, the time that I am exposed to the sun is longer than if I am down here where I am at my elevation.
Yeah, increasing your observer height would allow you to see farther on a flat surface too.
Yes, but realistically, if I were on a flat surface, then the thing is that if I have a strong enough light dampener, I should be able to see the Himalayas. Should I not?
No. There's an intense amount of atmosphere between you and the Himalayas, plus the light that's reflected off of them that's reaching you would be attenuated over distance. There's a lot of fine-tuning problems when it comes to that. No, that's just... Not to disrespect you, but that's a silly argument that I wish people would not use because it's simply not true. You would not be able to see indefinitely far just because the Earth is flat. That's not true. Angular
Okay, let me ask you a
resolution
question.
alone, like if you move an object away from you, it appears to get smaller, right? And this happens regardless of what optic you're using. So if you move a Himalayan mountain away from you really, really far, it's going to shrink to a dot, and you're not going to be able to see it anymore. So that alone would prevent you from seeing the entire Earth, you know?
The idea that, well, actually, so the thing that immediately jumped to my mind was the fact that when the sun is lower to the horizon, or it's lower to the, it's through thicker atmosphere, it generally tends to be bigger. So,
Yeah.
um,
Yeah, you're seeing it. That's called what is that called? That's magnification. I forget what they call that. It has to. I think it has to do with like Rayleigh scattering.
it would just be a form of magnification. We don't need to argue the semantic terms here.
Atmospheric lensing. Atmospheric lensing.
Okay, yes, atmospheric lensing. So the same premise is what I thought would work with the Himalayas, but
No.
do you have evidence to support that the thickness of the atmosphere actually prevents us from seeing very far away through that amount of atmosphere?
The best thing that I could compare it to is fog, right? Because fog is a type of atmosphere you can't see indefinitely through fog. And the other simple argument that I could give you is if you shine a flashlight, it doesn't travel forever, right? Because light attenuates over distance.
Fog seems like a extenuating circumstance, though, because it's moisture. Fog is
but here's the problem, bro.
It's incredibly dense moisture.
No, there's moisture in the atmosphere that attenuates and absorbs light. Well, how do you think you're breathing?
Okay. Yes, but you're realistically, like, if you're using fog
if I have like 10 feet, if I have like 10 feet of atmosphere in front of me, that's one thing, right? If I have 10 miles, that's a completely separate issue, right? This is the argument that as it stands, right? If you increase the amount of atmosphere between you and a distance, the amount of attenuation, the amount of absorption and delineation of light, diminishment of light, if I can find semantics to whatever, it would increase as well, proportionally even. There's actually an inverse square law to light. It diminishes by 25% every time you double the distance. So, no, you can't see forever. And I love how we got onto this instead of, like, when you said we could prove that the Earth was curving. Because none of this does.
Realistically, the premise of it was just a site of how if it was a logical, it was a line of logic.
Well, it works on both models, okay? If the Earth is flat and you have an infinite amount of atmosphere that's going to attenuate light and things are going to appear to get smaller and a variety of other variables are going to occur, then you would see very similar things. In fact, if we were on a sphere, the horizon would appear to dip down and away from you as you increase your observer height, but it doesn't seem to do that much, and if it does, it's usually a result of angular resolution as well. Convergence, compression, these type of perspective-based arguments.
Let me go back to this other thing that we were talking about last time you were up here. Because I think I found the paper.
The microwave thing?
No.
Oh.
It was as far as the synopsis goes, it was a lot of different, because here's the thing. We were talking about battleships and the fact that they have to go through the atmosphere for their ordnance. And then you brought up sonar.
Yeah.
You brought up sonar going through water.
Yeah.
A liquid medium, you can travel in any direction.
I used that to say that when we map out the ocean floor, we assume it to be parallel with the surface of the water. We use sea level as a hypothetical datum. NOAA admits this, right? We use Euclidean geometry and 3D Cartesian coordinates to map this out. It's literally impossible on a sphere. So if you were to bring up anything naval, that is the best argument. You have to assume the Earth is flat to do anything. You also have to assume it's motionless. That was my argument. Do you know what a 3D Cartesian coordinate system is?
I do not.
Okay, I'll show you. 3D Cartesian framework. We'll just go to Google Images. Here we go. Flip my camera around. Okay, so it would be. You're gonna have to make me bigger if you want to see it. You don't have to keep me there, just for the sake of argument. So, you would assume XYZ axis. This is probably the better one, right? You would assume that this red right here is the ocean floor. And then you would measure on your y-axis how deep the ocean floor is. But you would assume it to be parallel, because you can't have a 3D Cartesian coordinate system without all of these lines being perpendicular to one another. They always have to be perpendicular at right angles. So if you go out 100 miles and you assume that the ocean floor is flat and you assume that the sea floor is parallel to it, then for 100 miles you have to assume that the Earth is flat, which causes major problems for the sphere, because obviously that wouldn't work. And it's all done using Euclidean geometry, planar measurements, bathymetry.
Except the problem with that is if there's curvature, then you're compensating for that, because like the area beneath you is smaller, and you're going to. So realistically, I guess the best analogy would be, so if I'm 50 miles away from a baseball, and there's another thing that's 50 miles away from me, the distance that I'm moving on the baseball in relative to it, like in relation to it, is actually not that far, I am moving a lot of distance.
You would have to assume spherical geometry, bro. You would have to assume it. Like, that's just, there's a difference between Euclidean and non-Euclidean. You use Euclidean geometry, right? You would have to assume non-Euclidean geometry, but that is in fact not what they do.
We are 1/7 millionth of the actual.
That's not
in scale.
That's not the argument. We map out the ocean floor by swathing up to 20 miles at a time. Sometimes even longer if you incorporate like convergence zones. It's insane. You can get up to like 450 square miles using multiple boats, right? You can do multiple boats, multiple pings from each boat, and you can get out like about 450 square miles with the incorporation of convergence zones, all assuming that the sea level is flat, literally flat, and that's assuming that the ocean floor is parallel to it. So you have to assume a 450 square mile flat grid. It's a huge chunk of the sphere, bro. Huge.
A 450 square mile flat grid?
Yes, that's a massive chunk of the ball.
The 450 square miles is less than Los Angeles, and there's 300,000 Los Angeleses on the globe. Like you can fit 300. Actually, it's like 392,000 Los Angeles. That's
how do we compensate for the curvature that would be within that distance then, since we use it on a Cartesian coordinate system?
Okay, let me, because there's stuff that I simply have not heard of. Okay, so
like I have these, the C-beam can sweep up to 5 miles. The Hydro sweep can sweep up to 8 miles. The C Mark II can sweep up to 21 miles. And then you would use multiple boats, right? Roughly 10 to 20 miles apart. And you would get like a massive measurement using that. And I like to say that we, when we map this out using 3D Cartesian coordinate systems and Euclidean geometry, we have direct precision, right? We make like no errors. The seafloors are like completely mapped. So
mathematically, hold on. Mathematically, the Cartesian coordinates, we can actually we can actually translate them to a sphere. You do know that, right?
They actually do. I'll read what they do. They take the distance and angle of the seafloor relative to the ship's transducer, okay? Like the actual instruments that they use, okay? Seafloor points are then, I have this all written down. Seafloor points are corrected for the ship's roll, pitch, and yaw using this thing called an inertial measurement unit. It's sort of like a gyroscope with the incorporation of an accelerometer. And then you take absolute physical location of the Earth, okay? In geodetic translation, okay? They translate it to a geodetic model at post-process. They map it out flat, but then they mathematically process it into geodesy, which we touched on earlier. They have to incorporate 7/6R, make the Earth bigger and smaller as needed, right? Because obviously it doesn't work. And then finally, when they chart it out in a finalized format, they map it out in a flat, usable map with minimal distortion for navigation and analysis in a projected Cartesian grid. I have all the notes I can show you.
Okay, because, yeah, what is the problem with that, though?
You take flat measurements, assuming the Earth is flat, sea level's flat, the ocean's floor is parallel to it. You map it out on a ball mathematically after the fact. You already took the flat measurements in reality. In reality, you had to assume the Earth was flat, right? In reality, you had to take flat measurements using flat math, okay? But then you take it into geodesy, you make the radius value and the ball bigger and smaller as you need it to make it look like it works on a ball. And then they go as far as to map it out on a flat map anyway. You know what I mean? Like it's sort of like
So
I don't even have a fallacy for
okay,
this.
I
It's just insane.
understand. I understand that sentiment. Like, oh, okay, my internet cut out there for a second.
You're good.
Okay, so I understand where you're coming from because, like, okay, so if we look at the world map, like Russia is like, if we actually look at the square map, that's just like straight across. We have equator here. We have like
That's not the argument.
like just the flat map.
It's not the argument.
No.
In reality, we take flat measurements.
I
We
am
have to.
justifying what you're saying.
No,
dude.
you're
I'm
not though.
justifying
Listen,
something so
because
that-
you're not even attacking. You're not attacking my argument. You would have by now if you were going to. Like, you actually can't. You can't make this work on a sphere. In reality, when they're actually on the water using naval, they assume the Earth to be flat. They assume a horizontal datum, that being the sea level, okay? They assume that that's parallel to the ocean floor, mapping out using 3D Cartesian coordinates, which I showed you, okay? Literally broke down the entire mathematical process from start to finish. That's how they do things. That's how they do things. That's how they do things in reality, okay? In the real world, where we don't assume the Earth is a sphere, but when we need to map out a model mathematically, then we have to tell people that it's a sphere. Otherwise, people will start asking questions, right? So they have to do geodesic. They have to change the radius value. They have to make the Earth bigger. They have to make it smaller. It literally doesn't even work unless you do that. And then they finally just chart it out on a flat map. Isn't that just like, in reality, though, they have to assume the Earth is flat?
So I was going to actually like make sure that I actually understood what you were saying, which yes, you did explain it again, but I was trying to piece together so that I could use my own lingo to try to understand what you were saying. I was trying to find your headspace in that last sentence before you interrupted me. That is what I was trying to do. So, damn it, I've lost my train of thought. God.
It's cool. In reality, we assume the Earth to be flat. In mathematical post-process models, we make it a ball so that people don't think that it's not. That's literally what we do.
Okay. The problem.
I'm sorry. Go ahead.
Are you good?
Yeah, I just said I'm sorry. Go ahead. It's okay. Like, there's no argument against this, bro. There isn't one.
I am trying to figure out how to act. Oh, what?
There isn't an argument about it. In reality, we assume it's flat. You have to, or else it doesn't work.
Okay. Okay. Let me see here. Oh, somebody let him up. Okay. Eva. Hi.
Hello.
Okay.
Do you have an explanation for this, Eva? Why we have to assume the Earth is flat, and then
Yeah, I was working
mathematically?
through that.
Hold on, I'm almost done.
Yeah.
And then mathematically program it into a ball to confuse people into thinking that it is one?
So if the refraction factor is 7/6, What is the refraction
Are
coefficient?
you not
that goes
answering?
with that?
You're not answering my question. Why do we have to assume that the Earth is flat to do bathymetry? We're talking about sonar.
Because we don't.
I just
So
showed
now
it. Do you want me to show it again?
No, I would
Oh,
like an
so
answer to my
you're gonna
question.
come up here and lie?
Yes.
Have you recorded, you idiot? Oh my god.
So if the refraction
No, I'm
factor
actually no. I'll take the W.
is
I'll
7
take the
over
W.
6.
You guys have a good day. You just lied to like 50 people
Run
and whoever
slowly.
sees this when I post it.
Run
Have a good day, bro.
slowly.
I'm not running. You just called yourself a
Run.
liar.
Run.
Peace, bro.